I'm graphing is a no-no when the lines don't cross real clear. So I put down my graph paper. My students want to eliminate. They see it, they say, oh boy. Tell Murphy, line it up on the top and bottom row. Make coefficients both the same. Get one plus the other minus. Those are the rules of this game. Multiply or divide. That's the only way to get your coefficients right. These additive inverses, y got x or y. Whatever's easier is what you have to decide. All we do is solve. You solve for x, I ain't solve for y. Eliminate with me, cause I'm always solving right. Solve no matter what. Got systems on my mind, I can never get enough. And every time I step up in the classroom, all my students' hands go up. Can they stay there? Can they stay there? Can they stay there?
Well, hello there, Algebra 1 students. Welcome back to our third installment in Systems of Equations. And I know you've been enjoying those songs, those videos, kind of in their segments. We're into solving the systems by elimination this time. And so we're just going to get right into it, starting to look at our first cartoon. So solving by elimination 5.3 in the Algebra 1 for Big Ideas. And so we have our cartoon here. Got some dogs sitting at the dining table here at eating out in a menu. Yeah, I'll have the math homework, please. Of course, because dogs eat our homework, right? That's it. Alright, so let's move on to looking at the core concept. So this is just something to keep in mind, keep in front of you. Look at that as you're going through. There's got the steps there. I don't necessarily need to read through them so much. They are there. You can read through them yourself. But I think it'll be helpful, more helpful, just to show you with equations as we start just to get into our extra practice. Alright, so we are on page 145 here in our notes. And we're going to start just with the 1 through 6 where they're a little bit easier. It says solve the system of linear equations by elimination. And we're always going to start typically with the easier ones. Now it's going to be the process of elimination is what we need to be able to do is be able to cancel out and eliminate opposites. So we need to eliminate either the x or the y, and it doesn't matter the variables, remember. In this case we have x's and y's on all of them, but you can either easily have like a and a b or m and an n, something like that. It doesn't make any difference. But your goal here in the systems is, for one, it needs to be set up to where both of them are in standard form, and you can see the x's are lined up, the y's are lined up, even the equal signs are lined up, and then the numbers on the side, the constant numbers over here, are lined up. So that's how you see standard form is x plus y equals a number. And you have that in both equations. And you want to now either eliminate either the x's or the y's. So on all 6 of these, it's already set up just to right away quickly eliminate. So you're going to be able to quickly eliminate some of these. I'm going to come through, I'm going to do the even ones, and then I'll have you do the odd ones. So let's just take a look at number 2. So as I'm looking at these again, everything's lined up. X's, y's, and the constants are lined up. So what we're going to do is we're going to kind of combine these two equations together. We're pretty much going to kind of add them together. That's another way we could even call this. They call this the elimination method here. I've heard this called the addition method in other places, or even the combination method in other places. But basically we combine these two together, so we're going to be combined like terms here, giving us 7x. And when we combine these two, you cancel them out. They're opposites of each other. That's what we need to have. We need to have these, one of them, either x's or y's, be opposite. Equal sign comes down, combine the 5 and the 16 to give us 21, and now divide by 7, and we've quickly found what x equals. X does equal to 3. So now remember what we're trying to find here on every systems of equations is we're trying to find the ordered pair of x comma y where these two equations, if we were to draw them on a line, if we were to graph them like with the graphing method, where these two lines would intersect or they would meet. And so we know that the x coordinate now is 3. So to find the y coordinate, we're just going to choose one of these two equations. It doesn't matter which one. We can label it, like equation 1, equation 2. And I'm just going to choose equation 2 because the y is positive. I like that one better because y is positive. It just seems like it might be a little bit easier. So if I just write down equation 2, it says 5 I'm going to put the whole thing down here. 5x plus y is equal to 16. That's our equation 2. And I'm going to replace the x right there with 3. So 5 times 3 plus y is equal to 16. That's 15 plus y is equal to 16. And then we just subtract 15 from both sides. So those 15's cancel. So now we can see what y equals. Y is equal to 16 minus 15, which is just 1. So our ordered pair for number 2 here, the answer for number 2, I'll put it up here, 3 is x and y is 1. So it's 3 comma 1. All right, let's come down and try number 4. So number 4, same idea here for 4. We're going to combine them together. And right now when I combine the x's, again, they're all lined up. That's the first thing you want to notice for elimination method. Both equations are in standard form, x's, y's, and constants. So 4 minus 1 here is 3x. And then these two are opposites of each other. So that are the ones we can eliminate. We can eliminate those variables. That's why we call it the elimination method, because you can eliminate with the opposites. You even in the video even use the phrase additive inverse. These are the additive inverses of each other. They're opposites of each other. And then 6 and 3 make 9 here. Divide by your 3. And so that quickly gives us 3 for x again. So x is equal to 3. And then we'll do the same thing. We'll pick one of these two equations up here. And I'm going to just pick I'll pick the top one. I'll pick equation 1 this time to be the equation we'll use. I'll put it off to the side. So 4, I'm going to just put in my x right now. 4 times 3 for x. Then plus 3y is equal to 6. And so this is going to be 12 plus a 3y is equal to 6. Subtract 12 now, minus 12 on both sides. And you get canceling the 12s, 3y is equal to, if I take 6 away from negative 12, it's negative 6, and then we just divide by 3. So y is equal to, this is going to be negative 2, negative 6 divided by 3. So there's our answer. I'll put it in red. So our answer here for number 4 is 3 comma negative 2. You always want to put your answer in ordered pair form because it represents a point, the intersecting point of these two lines. So always it represents an ordered pair. All right, number 6 I'll come and do. Different color here. So combine here, combining the x's, they don't cancel out, they combine to give us 5x. And combining the y's here, they cancel each other out. Now you might be thinking, this is great, this is easy, this method, why don't we just do this all the time? Well, it's not always as easy. Right now, these are all set up to where it's already ready to just eliminate. In the future, in the ones to come, it's not going to be as easy. So we take 8 away from 13 here, that's going to be negative 5. Divide by 5, and we're going to see x on this one again, is equal to negative 1. Are we always going to eliminate the y first? No, not always. In fact, you can see on these other ones, you're eliminating the x first, actually, on all these other ones. So apparently the even ones, we're eliminating the y's, and the odd ones, we're going to eliminate the x's. Alright, so now we know x is negative 1. Choose one of the top equations. I'm going to choose equation 2 again, right over here. So 3 times x, so 3 times negative 1, then plus 5y is equal to negative 13. And this is going to be negative 3 plus 5y is equal to negative 13. And then we're going to add 3. So just going back to simple solving equations here. So cancel those. 5y comes down. And take 3 away from 13, that's a negative 10. And divide by 5 to find out what y is now. So y is equal to negative 10 divided by 5. That's a negative 2. So here's our ordered pair. I'll put it in red again up here. So it's going to be for x, negative 1. And for y, it's negative 2. Negative 1 comma negative 2. You can always check this as well. You can always check anything for systems of equations because you could plug this back into both of these equations as long as it works for both. When you plug it back here, as long as this one equals 5 and you plug it here, it equals 16, you know that's the correct point. Alright, so go ahead and pause the video and you're going to try 1, 3, and 5. You're going to be eliminating the x's though. That's the only thing different. Solving for y first and then plug the y back in to one of the equations. and solve and find x the second one. Alright, so go ahead and try 1, 3, and 5. Go ahead and pause the video and then play it again just to check your answers. Alright, hopefully you've paused the video and now you're playing it again to check your answers for 1, 3, and 5. So let's go ahead and try and find. So here's our answer for 1. So you should have got positive 2, positive 5. X is 2 and y is 5. So here's how you can do it. You can see the work there for that one. Number 3. This one, the answer should be -1, 4. X is -1, y is 4. You'd find the y first, and then you plug y back in. I chose to plug it into the top one, but you could plug it in either one. It doesn't matter, and you should get the same answer for x, -1. And then for number 5, the answer for that one is -4, -4. Both x and y were -4. So you're canceling the x's out and solve for y first. You get -4. Plug -4 back into one of those two equations. I chose the second one. And I got -4 also for x there as well. Alright, so I'll leave that there for just a minute. You can go ahead and pause it if you need to, look at this a little closer and see if you missed something. Definitely pause it and see if you can figure out why you made that mistake before moving on. Alright, but I'm going to go ahead and move on to our next section. Alright, so when we're doing the elimination method, our goal is to have them like 1 through 6. And we were just doing where they're in standard form, first of all, and they're in the position or in the situation where you can have just canceling out or eliminating one of the variables right away. So we're going to see here on these problems that we're not going to be in that situation. Either they're not going to be in standard form or they're not going to be able to just cancel out right away. So we have to do some adjusting. So a lot of times before we actually can get to what we did on 1 through 6, we do have to do some adjusting first. So let's take a look at 7 through 9 and see how we're going to need to adjust some of these. So what we're going to do, noticing on 7 through 9, they're not both equations are not necessarily in standard form. This one is actually more in like this form for substitution. We could substitute for y equals this. So we could do that. You could use substitution right now. 2x plus this right here is equal to 12 and solve it the way we did it on the last lesson. But we'll need to adjust these. We would need to, if we're going to try to use elimination, we would move the y to this side and move the 18 the other side. So basically switch places with the 18 and the y. I'm going to do that on number 8. I'm going to have you come back and do 7. I'll do 8 and 9. So in this one we have the top equations, x plus y is equal to a number, but this one is not. So we need to definitely adjust this. We need to switch places. Actually, I need to basically just move the 4x on this side. So I need to subtract 4x here to bring it over here onto the side. So it cancels them there. Now I just have the 6 on this side. Put the x term first. So I'm going to see it's going to be, I'm going to put it right in between here. I'm going to see -4x, and then I'm going to see my positive 2y, so I'm going to put plus 2y is equal to 6. Alright, so if we can see that. So that now is the two equations I want to look at. Here's my equation 1 and my equation 2. So that's now the two in standard form, and I can go ahead and see how I might eliminate the x's here. 4x and -4x, those are opposites. They will definitely eliminate. So I'll cancel those out. Combine these two, which is 3y and 2y. So we're going to now have 5y is equal to 14 and 6 is 20. So when I divide by 5, y is equal to 4. So I needed to adjust the second equation down here into its standard form so I can use the elimination method. And so now I can choose any one of these equations. I can even choose my original one here if I want to. It doesn't make any difference. Plug the y in one of these equations. And let's see, let's go ahead and just choose my top equation here, number 1. 4x plus 3y is equal to 14. I could have chosen the second equation that I adjusted or the original second equation. So I'm going to plug y into my number 1 equation here. So 4x, and then it's plus 3 times y, so 3 times 4 is equal to 14. That's 12, so 4x plus 12 is equal to 14. Everything else is the same at this point. So subtract 12 now. And so 4x, line there, is equal to, so 14 minus 12 is 2. And when I divide by 4, I get 2/4. So x is equal to like 2/4, but 2/4 can reduce. So we can cross this out. 2 becomes a 1, 4 becomes a 2, 1/2. So x is 1/2. This has got a fraction as an answer here. So x is 1/2, and the y is 4. Alright, so you can always check your answer to see if that would be true. If you plug this back in, and we can say, okay, if I plug it in here for 4, 4 times 1/2 is going to give me 2. 2 times 4 is 12, and then 2 and 12 make 14. It worked there. And you can do it here too. Half of this one is going to be 2 as well. 6 and 2 is 8. 2 times 4 is 8. So it works in both equations. That's the correct answer. Now if we take a look at number 9. So number 9, we're going to have to adjust both of these equations. They're both not in standard form. So we need to move both of these over. So I need to subtract my 4y from both sides on this one. And so that's going to end up giving me, I'll put it over here, I'm going to put my negative 4x first. X term first, then minus 4y, and then it's equal to the number, because those two are canceling out there, just equal to negative 2. And I'll do my next one maybe in a, I'll do a dark red here. So the next one I'm going to be adding 4x, add 4x. So it's canceling those 4x's there. So what this one now becomes, put the x term first, positive 4x, then minus 4y is equal to the number 1. And so now we're going to combine these two together, and we see that we are set up to eliminate the x's. So we cancel out the x's here. So we can cancel out these x's. So our y's here combined to negative 8y, and it's equal to, this is going to be basically taking 1 away from negative 2 is negative 1. And now I'm going to negative 8. So y is equal to a fraction. Negative over negative is positive 1/8. So 1/8, I got to plug that back in to one of these two equations for y. And it doesn't really matter which one I choose. I'm going to choose equation 2, my original equation 2. I could choose one of these two equations also, so it doesn't make any difference. So I'll just choose this one right here. Again, any equation would be fine. So when I plug it in, negative 4 times the 1/8. Negative 4 times a 1/8. And then it's equal to 1 minus 4x. So now I'm going to cross cancel 4 and 8. 4 becomes 1, and 8 becomes 2. So now this is basically a negative 1 times a 1/2. So that's a negative half. Negative 1/2 is equal to 1 minus 4x. Now I need to bring this 1 over here. So subtract 1 from both sides. Cancels them there. And if I subtract 1 over here, so I put minus 1, I'm going to make it a 2 over 2 so it has a common denominator. Whenever you're going to subtract and it's some kind of form of a, it's not a fraction yet, you need to make it into a fraction. And if it's 1, it's easy. Just put that denominator over itself. Any number over itself is 1. We want it to be a 2 because it's common denominators. So this is negative 3 over 2. And that's equal now to negative 4x. Alright, so now what we want to do, to be able to get x by itself, I need to kind of divide this. Since this is a fraction though, what I could do is I can multiply by the reciprocal of this. So multiply both sides. If I divide both sides by by a negative 4, that might be a little confusing. So it might be easier to think of it in this way, is to multiply with the parentheses by a negative 1/4. So negative times negative would be a positive, which is what I need my x to be. 4 is crossed out there, and now it's just positive 1. So that means I give x on this side, and it's equal to over here. We're going to multiply by the same thing, negative 1/4. And it's going to end up being negative times negative, so it will be a positive number. 3's on top, and 8's on the bottom. 3/8. So my answer is, again, two fractions here. 3/8, for x and 1/8 for y. Alright, so I'm going to have you try number 7. Try number 7 on your own. You have to adjust the second equation. That's the only one because this one's already in standard form. Just adjust this one. You can move 18 this way, add 18 to go over there, subtract the y to come over here. And then you'll be able to eliminate, looks like the y's you'll be able to eliminate. So go ahead and pause the video and do number 7 and then just play it and check your answer. Alright, so hopefully you finished number 7 and you're just going to check your answer now. So our answer for 7, you should have moved the 18, added 18, subtracted y to get this second equation in standard form. So our answer here on this one should have been 6, 0. So you should have got 6 for x, 0 for y. So I adjusted it, moved it to the top, so 3x is up there. And the y, negative y is coming over, so we can eliminate the y's here. Positive 18 is on this side. So 3x and 2x give you the 5x, and then you get 30 for that. It's giving you 6 for x. And I just plug 6 back into the top equation here. That's giving me 12. And so when I subtracted 12, I got 0 for y. Alright, now when we come to number 10, you'll notice here they're in standard form, so there's no adjusting that way like we did on 7 through 9. They are in standard form, but what about eliminating? If I combine these together, I'm going to get 3x, I'm going to get 3y. There's no eliminating. I don't have that ready to go. So I'm going to need to choose a variable to eliminate. Sometimes it's already chosen for me, like all of these, they were chosen for us. We were going to eliminate the x's here because they were opposites. Eliminated the y's on this first one, 7, because they were opposites, so it was chosen for us. But now, when it's not chosen for us, we have to choose a variable to eliminate and adjust them so that we eliminate that variable. So, if I choose to eliminate, let's just say I choose to eliminate the x on this one. I want to eliminate x and not y. So I'm going to eliminate the x's. That means I need to make this x here on the first equation a -2. So I need to multiply it by a -2. So we're going to adjust these always by multiplying them. We're going to multiply the equations so that we can, basically manipulate them to become what we want. And so since I want this x to say -2 in it, -2 in front of it for a coefficient, I'm going to multiply it by -2. Now I can't just multiply the x only. I have to multiply the entire equation all evenly by this -2. I got to increase every term there by -2. So -2 times x is -2x. I'm just going to put it below this one. -2 times the 2y is -4y. And -2 times 20 is -40. And now I can combine these two equations. And say I've got the x's now set up to where they can eliminate. We can cross out those x's now. And we're going to get -3y is equal to, if I take 19 away from -40, that's going to be a -21. And then divide by 3. Divide by -3. And so we're going to see that y is equal to, on this one, +7. And now at this point, everything else is the same. We're just going to keep going like we've done before. Take the y, plug it into one of these two. I'll plug it into equation 2 here. So over here, equation 2. I'm going to plug in this y, so 2x plus y, which is just a 7, is equal to 19. And so I'm going to subtract 7. So 2x is equal to 12. And so when I divide by 2, 12 divided by 2 is 6. So that's just a 6 there. So our answer on this one here, we can see, is going to be, I'll do it in red, up on top here, x is 6 and y is 7. Alright, now sometimes you're going to have to multiply not just one equation, but you might need to multiply both equations to be able to adjust them and be able to do that and manipulate correctly. So I'm going to do number 11 here. We're going to adjust both of these equations because if I decide, okay, I want to eliminate the x's again, there's no way for me to multiply 3 by anything that's going to give me opposite of 4. And there's no way for me to multiply, even if I try to eliminate the 4, I can't make it into a -3. So I can't do that on either one of these. So what I can do, though, is I can multiply both equations and change them both. Now, just for space on this one, we're not going to do number 12. 12 would, is actually 12 is actually a little bit easier because we can adjust this one and eliminate the x's right away. Maybe I might do this one first, and maybe we'll do 12 and not 11 right now. So I'm going to actually have you do number 12, because 12 is just like 10. That way you get a chance to try this on your own and see if you can do it correctly. And then we're not going to do number 11 right now, so go ahead and you can cross that one out for now, because that one's a lot like 13 and 14, and we'll do those on the next page. So go ahead and right now try 12. Go ahead and pause the video. You need to adjust this bottom equation, eliminate the x. You're going to multiply the entire bottom equation here by a -3. It has to be opposite of 9. So 3 times a -3 will be opposite of 9. So go ahead and do that. And then just do everything else the same. Do the elimination method the same after that. Alright, so hopefully you've done 12, you finished doing 12, you're multiplying it by -3 here, so our answer for this one, when you did that, should be a 1, 1/2. So x is 1, y is a half, so when you multiply this one by -3, I just put it over here. I wrote the top one down exactly the same, just copied that one, and then -3 times 3x is -9x. That way it's opposite there for x's. We eliminate the x's. Then -3 times -10 is +30. -3 times 2, 6. So that's going to give us 34y when we combine those. 17 and divide by 34. 17 over 34 is a fraction that 17 can go into 34 2 times, so it's 1 over 2. 17 simplifies to 1, 34 to 2. So you got to realize that 17 over 34 is going to become a 1/2. Then we put in 1/2. And I chose this equation right here, just our original second equation. So that's when I chose to plug it in. You can choose any equation out of here. I just chose the one that's, usually has the smallest numbers. So you have the 3x minus 10 times, instead of y, we're putting in 1/2 there, equal to -2. Half of 10 is 5, so it's -5. Then you add 5 to both sides and get 3, and divide by 3, you get 1 for x. So that's why we got 1, 1/2. Alright, so again, you're not doing number 11, we'll go on to number 13. But before that, let's go to look at our joke of the day. So why does Humpty Dumpty love autumn? Why does Humpty Dumpty love autumn? Because Humpty Dumpty had a great fall. He had a great fall. Alright. Going on. That's funny. Now, number 13 through 18. We're going to do some adjusting on these ones, and these ones are going to be sometimes needing both equations to be adjusted, like we can see on 13. We're going to see the same thing happening on 14. We would see the same thing happening on 15 as well. Everything is in standard form. Both need to be adjusted, though. Alright, so I'm going to do 13, 15, and 17. I'm going to do the odd ones and have you do even ones on this one. That's because 16 is going to be one of the easier ones there to do. So starting with 13, we can see that they're both going to need to be adjusted here. I'm going to have to multiply both equations by something. First of all, notice they're in standard form. That's fine. You need to pick, since I can't just eliminate one right away, I'm going to pick a variable. It doesn't matter, usually I pick the smaller numbers though, so I'd probably pick y's to eliminate. So what I'm going to do is I'm going to multiply the top equation here. So what can I get 2 and 3 both to become? They can both go into 6. The closest number that both of those two can go into would be 6. See, if I was going to try for x's, 4 and 5, the nearest number would be 20. So that's why on this one it's a little bit more, it's a bit bigger. So that's why I choose smaller numbers, just to make it easier for myself. So on this one, to make this into a 6, just kind of multiply by 2. And for this one, to make this one into 6, multiply by 3. Now these are the same sign, and we need them to be opposite signs. So I need to make one of these into a negative. It doesn't matter which one, I'll just make the 3 negative there. Alright, so I'm going to readjust these. I'm going to kind of move them over to this side. So I distribute the 2 into this one. It's going to be 8x. And then 2 times 3 is our 6y. And then 2 times 21 is 42. For the bottom part here, negative 3 times 5 is negative 15x. And then negative 3 times 2, it's our negative 6y. And there you have the ones you're going to eliminate. So now they're opposites of each other. That's what we're trying to do. Negative 3 times 21, that's going to be negative 63. So now combine these two equations together. And we're going to combine the x's, take 8 away from 15, it's a negative 7 for x. Cancel out the 6y's. And here we're going to subtract 42, take it away from 63. So that's going to be a negative number, since 63 is bigger, it's 21. And you can take a little more time if you need to on some of these bigger numbers. Just make sure you don't make these simple little mistakes. If you're getting some kind of really weird answer, and then you might think, I might have made a mistake somewhere with just some of the easy, simple arithmetic here. So now you have negative 21, negative 7, so it's positive here, and 7 goes into 21 3 times. X is 3. Now we're going to go back. I would go back to one of the original equations because there's smaller numbers there to choose one from. And I'll go ahead and just choose equation 2 on this one. I'll choose this equation, 5x. So 5 times 3. And then plus the 2y equal to 21. That's going to give me 15 plus 2y equal to 21. So subtract 15 for now both sides. Notice this last step is the same step that was the last step in the substitution method as well. So once we know one of these, we plug it back into one of the equations to find the other one. So 15's cancel, 2y is equal to 21 minus 15. That's going to end up giving us 6. And it is positive because 21's bigger. So divided by 2, and that's going to give us 3 for y. So y is 3, they're both 3. So we got a 3, 3 for this one. Find a place to put our answer here on this one. Just stick it down. I'll put it in green. So 3, 3. That's our answer for number 13. Let's look at 15. So 15, we want to, 8 and 7 are bigger than 4 and 3, so I would try to eliminate the y's. So I'm going to adjust these first. So what number can these both go into? The closest number they can both go into is 12, because if you think just by 4 goes into 8, and 3 does not. 4 goes into 12, and 3 goes into that, so it's got to be 12. To make this into a 12, you multiply by 3. And to make this number 12, you multiply by 4. Same sign again, so one of them is going to have to be negative. I'll just make the 4 negative there. And let's go ahead and move them this way. So 3 times 8 is 24x. 3 times 4 is 12y. And 3 times 12 is 36. And then negative 4 times 7, move it this way as well, is negative 28x. Negative 4 times 3 is the negative 12y. So there's the ones that are going to be opposite. And then negative 4 times 10 is negative 40. So now we're going to combine here. And let's see, 24, I'm going to take away 24 from 28. It's negative though. So negative 4x there. Those cancel. And it's equal to, take 36 away from 40, it's also negative. That's going to be 4 as well. So if I divide by negative 4, x is equal to positive 1. Negative 4 over negative 4. Come back to choose one of the equations you want to use here between probably these two original ones since they're smaller. I'll just use equation 2 again. So equation 2 here I'm going to use. So 7 times x. So 7 times 1. And then plus 3y is equal to 10. That's going to give me 7 plus 3y is equal to 10. Subtract the 7. So 3y. Over here, when I subtract, I'm going to get 3 as well. So divide by 3, that's 1 as well. So 1, 1, our ordered pair for this one. I'll do it in red. This guy. So this one is 1, 1. That's our answer for 15. And then for 17, I'll come down and do this one, and then you go back and do the even ones there. So for 17, let's let's see, we need to figure out 8 and 5 or 3 and 4. So I would definitely do 3 and 4. They're already opposite signs, even better there. So I need to make them just like this one here, 12s. So you're going to multiply this one by 4, multiply this one by 3. And this one I don't have as much space, so I'm just going to have to put them maybe right underneath here. So 4 times 8, that's going to give me 32x. 4 times 3, negative 12y. Now I didn't need to make one of these negative because they're already opposite signs, so I can just keep both of those 4 and 3 on the outside here positive. 4 times negative 9 is negative 36. Then 3 times 5 is going to give me 15x. 3 times 4 is going to be positive 12y. See, they're opposites now. And 3 times 12, that's 36 here. So now when we combine, we're going to get 32 and 15. That's going to be 47. 47x. X's are going to cancel there. So right there, these two here cancel out. And over here also, these two are going to cancel. And that makes this equal 0. 36 and negative 36 equals 0. So it means x has to equal 0. If I divide 47, 0 divided by 47, x has to be 0 then. So if x is 0, plug in 0 for one of these up here. And I'll go ahead and use blue. And I'll just put it on the side. I'll choose number 1 this time, equation 1. And so for that one, put it kind of down here, 8 times 0, and then minus 3y is equal to negative 9. So y there. And so this cancels out because 8 times 0 is just 0. And now you just have negative 3 minus 9, subtract or divide by 3, negative 3 I should say. So y is equal to negative 9 divided by negative 3, that's a positive 3. So our answer for 17 here, x is 0 and y is 3. So 0, 3. Alright, so you're going to take a moment to do 14, 16, and 18 on your own. 14 is very similar. I would probably choose the 3 and the 4. I mean, they're easier. They're smaller numbers probably. These ones not too much smaller though. On this one, number 16, you're going to notice I would definitely eliminate the x's because all you're going to need to do is just adjust the bottom one. Because you can multiply this one by 2 and it's now opposite of that 4. That would be negative 4, opposite of 4. So just adjust the bottom one on this number 16 one. That's similar to the ones we were just doing on the last page. And then for this one, I would probably eliminate x's on this one. Just they're smaller than 5 and 2. 3 and 2 are smaller. So I would try that. So go ahead and pause the video and do 14, 16, and 18 and play it to check your answers. Alright, so hopefully you were able to finish 14, 16, and 18. I got a little extra space here just so it's not confusing, so you can see them clearly. So for 14, our answer for that one should have been a negative 1, comma 2. So negative 1 is x, 2 is y. And so we were eliminating the x's on that one. That's what I told you to do. And so we're going to become, there's our 12s. It will become 12s, but negative 12. I just made one of them negative. It doesn't matter which one you choose to do that. And so that's how y became 2 when you combined. And I just chose the second equation, the original second one, to go back into, plug y in there. So negative 3 times y is the 6 there, negative 6. And that's how we were able to figure out that x is negative 1. For number 16, you just need to adjust this bottom equation only. So I just need to multiply the bottom equation by a 2. Now I just wrote up here, just above it, of negative 4x minus 10y equals 14 when I multiply the bottom equation all by 2. And then when I cancel out the x's there, I'm going to get negative 7y, and then 14 minus 7 is 7. So I got y equals negative 1. And I chose the first equation here, the top equation, to go back into, plugged y in for that, got x is also equal to negative 1, so they're both negative 1. Negative 1 comma negative 1. And then for 18, this one the answer is 1/4 and a negative 1/4. So this one was probably the more challenging one of the two, or of the three I should say. So we chose, again, x's, just they're smaller numbers, so get them both become 6's, they're already opposite signs. So 2 times all of this one becomes negative 6x plus 10y equals negative 4. 3 times all of that is 6x minus 6y is equal to 3. cancel out the x's, and so you're going to get 4y, but negative 4, and then 3, that's going to give you negative 1. So you divide by 4, you get negative 4, or negative 1/4. Plug negative 1/4 back into one of these two. I just chose the bottom one here. And multiplying 2 times a 1/4, that's going to give me 2/4, which is a 1/2. And it's negative times negative, so it's positive 1/2. Subtract that 1/2 from both sides. 1 minus a half is a half. So now you have 2x is equal to a half. Multiply by the reciprocal of 2. The reciprocal of 2 is 1/2. Remember, reciprocal is just the number flipped upside down. If I put 2 over 1 and flip it, that's a 1/2. That's how you should do it when you do have a fraction in your equation. And so at this point, now we can see 1 over 1 times 1, 2 times 2 is just a 1/4. That's how we got x to be positive 1/4. Alright, coming to our last problem on the home stretch now. Alright, we always apply this to some word problems. There's always going to be word problems that are going to be needing to write a system of equations for. So that's what we see here. We have just a very short word problem, in fact, just talking about two numbers. So the two numbers in this is going to be just like x and y, the two variables. So it says the sum of two numbers, so this would be x plus y. So for this equation, we're going to get x plus y. The sum is equals 22. But this one, the difference is 6. So x minus y is 6. What are the two numbers? Well, just use the process of elimination. So we just combine these two together, eliminates the y's, so 2x. This one's a pretty easy one now. So the hard part was just writing it down, making sure you write it down correctly. We got 28 here, so divide it by 2, and so x is equal to 14. And then you plug that back into one of the equations. We can just go into the top one here. So if x is 14, 14 plus y is equal to 22. 22. Subtract 14 from both sides. And so we can see that y is equal to 22 minus 14. That's going to end up being 8. So there's our two numbers. So the two numbers are 14 and 8. So you want to see that they do satisfy these two. If you add them, they both become 22, and if you subtract them, they become 6. So yes, that's true. So 14 and 8 are going to work. Alright, so that concludes our lesson on solving systems by elimination in 5.3, and I'll see you on the next one. Have a great day.